Okay, so we're going to talk about parallelograms. Actually, real quick, on the back of this paper, I want you guys to draw. This can take up a lot of the page if you want. We'll label this polygons. Yeah, this is on the back. So we have lots of different types of polygons that we talked about. We're going to look at parallelograms today, that's a group that's inside of another group. How many sides does a parallelogram have? Four. What is the name for a four-sided polygon? Quadrilateral. Okay, so we have this category here called quadrilaterals. That is inside of polygons. And so then inside of quadrilaterals, there's a specific type called parallelograms that we're going to talk about today. And then next class, we're going to talk about some special types of parallelograms. Can you guys think of what I'm talking about? Special types? Rectangles. Yep. A little small here. What about any other special types? Squares. And there's one more special type. Rhombus, yes. So there's rectangles, rhombuses, and they overlap, and when they overlap is squares. Ooh, kind of hard to see. Kind of small. Maybe I'll make that a little bit bigger. Okay, can you guys think of any other types of quadrilaterals that are not parallelograms? Anything else that has four sides that's not a parallelogram? Trapezoids, yes. So we'll talk about those too. They're their own group. And there's like one other type of quadrilateral that we talked about. You might remember. On a diamond. You want to know what that's called?
Which looks like a...
Hmm? Let me exaggerate it a little bit. Here's another example. Kites. So kite is its own group as well. So today we're focusing on parallelograms. So that's this circle right here.
So are we going to be working with rectangles, square, rhombuses?
Yeah, that'll be next class. But everything we talk about today is also true of rectangles, rhombuses, and squares. And they're going to have their own special properties too that are specific just to those shapes. So yeah, one thing that we want to talk about with quadrilaterals that's true of all of them. Quadrilaterals, of course, have four sides. And the angles add to, does anyone know what the inside angles add to? 360. Okay, so that's true of all four-sided shapes. Angles add to 360. That's just something good to keep in mind as we talk about specific properties of a parallelogram. But all these quadrilaterals that we talk about. So lots of different kinds, lots of special properties. Okay, so parallelograms specifically. A parallelogram is a quadrilateral with opposite sides parallel. That's why it's called a parallelogram, because the opposite sides are parallel. So remember that we can show that something is parallel with these arrows. We talked about parallel lines a good amount this year. Okay. Now, there are some special things that happen because of that. It's also true that both pairs of opposite sides are, anyone know? Congruent, yes. So sometimes people think that that's only true in a rectangle. That's not true. That's true of all parallelograms. Opposite sides are congruent or equal. Just a reminder, means equal. Yeah. I don't know why I talked about opposite sides. We know that already, so we can cross that off. Opposite angles, anyone know, are congruent. Yeah. Okay. So we have opposite sides congruent, opposite angles congruent. Of course, we have the definition, which is the opposite sides are parallel. Okay. Diagonals blank each other. So diagonals, remember, connect the non-consecutive what you call them? Vertices. Any guesses what's going to go in there? Huh? Cross? Well, all diagonals would cross. Let's be something. So we could say like intersect, but like all diagonals intersect each other. So diagonals bisect each other. What does bisect mean again? What does bisect mean? Over? Sorry, say that again. Two lines that cross each other? That's intersect. They cross in the middle of the line, yes. Okay, so it means that, yes, they cross in the middle of the line, or another way we can say this is they cut each other in half, exactly in half. They intersect at their midpoint. So that bisect means cut into or divide into two congruent parts. Or another way of saying that is both diagonals have the same midpoint. So there's just a few ways to say the same thing there. Okay. And then last but not least, consecutive angles. Close, not complementary.
They add up to 180.
They add to 180. What's the word for that? Supplementary. Yes. How do you know?
I guess.
Okay, yeah, so with parallel lines, the alternate interior angles were congruent. What was true about the consecutive interior angles? Yeah, it's the same because these sides are parallel, right? So when we have this transversal, like if this is 80, that's got to be 100. And so the same thing's just happening here. It's just because the sides are parallel. So it's kind of hard to draw this with symbols, but you can say it there. Those add to 180. These add to 180. So any angle and the angle next to it add to 180. So an example that you can see with numbers is it could look like this, where you have 80s and 100s. Of course, it's going to be different angles. Okay, so those are all the properties. And so remember, all of those properties are true of a rectangle. A rectangle has opposite sides congruent, opposite angles congruent. So it would just be 90 degrees. All right, so here's a rectangle, all 90 degrees, but opposite sides congruent, opposite angles are congruent, right? They're both 90. Consecutive angles are supplementary. They add to 180. 90 plus 90 is 180. The diagonals of a rectangle, they do bisect each other. And opposite sides are parallel. And then there's just some more special things about a rectangle, like all the angles are 90 degrees. The diagonals are congruent. But those are like extra things. But everything that's true of a parallelogram is true of a rectangle, a rhombus, and a square, and all the other types of parallelograms that just look like this. That's one thing we want to remember. Okay, so I want to look at some ways where that plays out with math. Could not get that document to print up here, despite my greatest efforts. It was quite annoying. So I'll just draw them up here. So number 1 on there. 11. So if we know that this is a parallelogram, what would the relationship be between x and 111? Yeah, so we would just do x plus 111 equals 180, and then we would solve for x by doing what? Subtracting. Okay, so in number 2, it's not a very good looking parallelogram. What would x equal? X would equal 52, yeah, because those are opposite angles, and opposite angles are congruent. So that's kind of a basic level problem. Both of those. A little parallelogram. In number 3 there, here's more what our problems are going to look like. Turn to your neighbor, what equation would we set up for solve for x? Okay, so would it be right to say 17x minus 4 equals 65? Would that be right? No, that would not be right. Those aren't equal. What is true about them? Abby?
Well, they're on the same line, so they're going to equal 180.
Yes. Those are consecutive angles. So this would be our equation. So it's 190. And what does x equal when we solve that? Did I do it right? What is it? 7. So very similar to stuff that we've done all this year, right? If we know that two things in a certain position add to 180, we can set up an equation where we add the pieces. Okay, let's go to number 11 on the next page. All right. If this is a parallelogram, what would my equation be to solve for x? Answer's 1. I think it would be 1 if it was 2x plus 9. 2x plus 9.
Oh, sure.
What would our equation be?
They're equal
They're equal. How do you know?
because we're on opposite sides.
Yes. Okay, so we know that opposite sides are congruent, so we set them equal. Yeah. So again, we're using what we know about the properties. Let's go to number 13. Okay. What equation would solve for x in number 13?
They're equal.
They're equal. Yes. What are these?
Bisect.
Yeah.
Oh, wait.
Yeah. So this is yes. This is one diagonal right there, and we know that this diagonal is bisected by the other diagonal, which means that both halves of this are the same. Yes. Let's look at number 17. This one has actually a few different ways that I can think of on how to solve it. Well, it's really just one way, I guess, but any ideas on how to solve this? Homer. 7x plus 7 plus 60 equals 180. Do we agree? No, that's not quite it. I think there's a little bit more. Okay, so we need to also add the 85. So if we just look at those two angles, that's this angle right there and that angle right there. Those aren't quite the consecutive angles. The consecutive angles would be all of this right here. Like this is the full angle that we want to add there. So we need to add all three of these to 180. That's one way to do it. Or what would this angle equal right there? That would equal 85. How do you know, Brad? Yes. So those are alternate interior angles. And then right here, this triangle, what do the angles of a triangle add up to? 180. So we also have that same equation. So two different ways. Adding up a triangle or seeing that this and this are consecutive angles right there.
So if you know those are consecutive, so then you know the whole thing's 120, and that side is 85, then you know that the other side is 25, right?
Yeah.
Then you have to do 7x.
Or 35.
Yeah.
Yeah.
So 7x plus 7 equals 35. You do that, right?
Yes. Yes, absolutely. And notice like that does get us to a very, like right here, we have that you could find by having all that be 120, or if you know all that's 120, you know, okay, this has to be 35, yes. So we could skip straight to 7x plus 7 equals 35. Yeah, very nice. So a few ways to come up with that. Okay. Now let's go to the very last page.
The last one was actually was 4.
Yes. Okay. So the last type of problem that we're going to be doing is given 4 points on a graph. We want to figure out from the properties if this is a parallelogram or not. So one thing that I think it's helpful to do is draw a picture and label it A, B, C, D. If you have graph paper, it's going to be even more helpful to put these points on a graph where they actually go. You can see it a little bit easier. I don't have graph paper up here. You guys might not have graph paper. So I find it helpful to do this, and then also label the coordinates. It's not exactly where they would go on a graph, but it just gives us an idea. And so what we're trying to do is it says we can use slope, distance, or midpoint formulas to figure out if this is a parallelogram. Our goal would be to use those things to try and identify one of these properties here. So if we could prove this, that the opposite sides are parallel, then that would work. We could also prove opposite sides are congruent. That would work to show that it's a parallelogram. We're not going to be able to show that opposite angles are congruent on a graph. We don't have any way of measuring the angles using slope or distance or anything like that, unfortunately. But we could potentially show that the diagonals bisect each other or that they have the same midpoint. And we're not going to be able to show that the angles are supplementary. So these are our goals. Show one of these things. We don't need to show all of these things, just one of these things. So how could we show that opposite sides are parallel using slope, distance, or midpoint? Which one of those would show that opposite sides are parallel? Slope, distance, or midpoint? Slope, yeah. So we could find the slope of all four sides. And we know that parallel lines have what? The same slope. Okay. So we're basically going to do this one 3 different ways. You don't have to do the rest of them 3 different ways, but I just want to show you all 3 on the first one. What is the slope formula? Rise over run. Okay. Say more. That's slope intercept form. The m part of that is the slope. So how would we be calculating that? Wait, y1. Yes. y1 minus y2 over x1 minus x2. Or we could do y2 minus y1 over x2 minus x1. So we can go in either order. Yes. This is what's known as the change in y over the change in x. Yeah. So the way that I like to find slope, this might be, if this is confusing to you, feel free to just plug it into the formula, but I don't love formulas. So if I was finding the slope of AB, I would look at the y coordinates first and say, okay, from 2 to 1, how far did I go up or down if I'm going from 2 to 1? Down 1. So I would say, okay, that's down 1, and then from -5 to 10, up 15. So that overall slope is -1/15.
Can we prove they're not a parallelogram if we prove one of them is not?
Yes.
Okay.
Mm-hmm. Yeah.
What was the question?
It's basically like, is it definitely a parallelogram, or maybe is it not a parallelogram? And so, yeah, what we find is going to determine yes or
So
no.
in the other one, it's 7 up, down 1.
Down 1.
And also up 7, 15.
Also up 15. Yeah. Okay. So that means these sides are parallel. Yeah. We have to do the other sides. So again, like, I'm just looking at the change in what happened to go from 7 to 6, that's -1. To go from -8 to 7 is +15. And so my slope would be -1 over 15. If you don't like doing that way, just plug it into the formula. So if I'm finding the slope of AD, I would just do y1 minus y2 over x1 minus x2. So that would be negative 5 over 3. And then we would do the same thing for BC. So 1 minus 6 over 10 minus 7. Okay, yeah, that is negative 5 over 3. And that proves that these two sides are parallel. So this is one way that we could answer the question. Is this a parallelogram? Yes. So we would say yes, ABCD is a parallelogram. And we would say because opposite sides are parallel. Remember that you can abbreviate parallel with this symbol right there, that's just 2 lines. Okay, so this is one way that we could prove that this one is a parallelogram. And again, if we were just doing this, you would be finished with the problem. We're going to show the 2 other ways just so that you can see what they all look like. I'll just do it on the same one because we know that this is supposed to be a parallelogram. We know the answer is yes. Okay. If we were trying to prove opposite sides congruence, would I use slope, distance, or midpoint? Slope, distance, or midpoint? What would prove the opposite sides congruent? Which one of those has to do with length? The length of the sides. The distance formula. Does anyone remember the distance formula? The distance formula is this. Distance equals the square roots of x1 minus x2 squared plus y1 minus y2 squared. The distance formula is actually the Pythagorean theorem. It's a squared plus b squared equals c squared, which is interesting. We'll probably talk more about that later this year. We won't do this whole problem here, but we'll set it up. So if I were finding this distance from A to B, I would have to set up the distance formula and say, okay, x minus x, so 10 minus negative 5 squared plus 2 minus 1 squared. This would be the square root of 15 squared plus 1 squared. And then we would check side CD. So if I did CD, (7 minus -8 squared plus 7 minus 6 squared. The order does not matter for distance formula. Okay, because when I square the numbers, they become positive. So this also is 15 squared plus 1 squared. So are those two sides congruent? Yeah. So that shows that they're congruent. And then we would do that for the other two sides as well. We've already proved that this one's a parallelogram, so I don't want to. Okay. The last way I think is the shortest and best way. Let's save the best for last. So we could prove that the diagonals bisect each other, or see if they do. It's better. It's probably a better way to say it. Would that be using slope, distance, or midpoints? Midpoints. And so we would be looking to see if the diagonals, what? Bisect each other? Well, what's another way to say that using the word midpoint? Have the same midpoints. Yes. Okay, so what is the midpoint formula? Anyone remember? So the midpoint formula is the average of the x's to get the x coordinate, the average of the y's to get the y coordinate. So your answer is going to be an ordered pair like that. And so we're looking at the diagonals. So if I'm finding the midpoint of AC, it'd be 7 plus -5 over 2, 6 plus 2 over 2. What is 7 plus -5? Seven plus -5? Seven plus -5? Yeah, 2 over 2. And 6 plus 2? 8. 8 over 2. So our midpoint is 1, 4. That's the midpoint of AC. Then we would need to check the midpoint of ED. So how would I set that up using the midpoint formula for BD? -8 plus 10 over 2. 7 plus 1 over 2. Okay. So again, that's 2 over 2, 8 over 2. Do they have the same midpoint?
Does it matter what order you're in?
No. Because when you add them together, they're going to equal the same thing no matter which way. Yeah. Yes. Yeah. Yeah.
So I could do
That's right.
7 and 1 and 1 and 7 and -8 and 10. Make them all.
Mm-hmm. Yeah. Make sure it goes x then y.
Yeah.
Add the x's together, but yeah,
But
the
it could
orders.
be x2 plus x1 and y1 plus y2.
Yep. 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 So this one, the order that matters is x then y. Distance formula, the order doesn't matter at all. It can go you could do y2 minus y1 squared plus x1 minus x2 squared. The order can switch. Slope, it matters. They have to have the same order on the top. Okay. So 3 different ways. I think this is my favorite way. This is the fastest way, in my opinion. This is the way that I came up with all these problems. I picked coordinates that would have the same midpoint because it was easier to think about that. So yeah. Okay, so that's it for parallelograms. That's all the different types of examples.